The second method by iteration is called back substitution. So we start from the end and we go back n minus 1, n minus 2, and etc. So the solution for this recurrence relation is already on the slide, but let me show you how did I get these steps and how did we find the solution. For a title, so we will have a title, back substitution. It is very simple to understand, but stay focused. So you have to find some of the terms. So as a draft, what I will do, and I'm going to call it here a draft. So this is a draft. Since each term depends on a previous term, let us find the equations in terms of these previous terms. This is given the equation for an. What if I want to find the equation for an minus 1? So what is the equation for an minus 1? Simply you remove n and put n minus 1. So if you remove n and put n minus 1, on the left hand side will be an minus 1. On the right hand side it will be 8 multiplied by an minus 2, because n minus 1 is minus 2. Find now the equation for an minus 2. So an minus 2 is equal to 8. Again, if you look at the equation, if this is n minus 2, so n minus 2 minus 1 will be an minus 3. Let us find for 3 terms an minus 3, and it is equal to 8 multiplied by an. So you can discover the pattern. If this is n minus 2, this is n minus 3, so the last one will be n minus 4. Now if I ask you what is an minus 4, it will be 8 multiplied by an minus 5. Leave those as a draft because you will use them for substitution. And let us start for our recurrence relation, which is an equal to 8 times an minus 1. Now this is step number 1. Step number 1. Now take the value of an, which is this equation, substituted in here, because an minus 1 is equal to this equation. So substitute it here. So what you will get? You will get 8 multiplied by, now put the equation for an minus 1, which is 8 multiplied by an minus 2. And 8 multiplied by 8 is 8 squared multiplied by an minus 2. And this is a step number 2. Don't find the final answer 64 because you will hide the operation involved for finding the answer. For step number 3, and notice here also, observe that I am using equal sign here. So what does it mean? It means this equation is equal to this. At the same time, it is equal to this. At the same time, it is equal to this. So all of these equations are the same, but they are written in a different form. Let's make another substitution. So an minus 2 is already given here. So substitute this equation in here. And the answer will be equal to 8 squared multiplied by 8 multiplied by an minus 3. And this will be equal to 8 raised to power 3 multiplied by an minus 3. And I will write here that this is step number 3. Since we found until n minus 3, let us do one more substitution in step number 4. So we will have 8 cube multiplied by See, the value for an minus 3 is here. So substitute this, put it inside here. And the answer will be 8 multiplied by an minus 4. And this is equal to 8 raised to power 4 multiplied by an minus 4. And this is a step number 4. So for each step, there is an equation. Now the question, when you continue this, at step K, if this is a step K, okay, and I'm going to write at step K, what this equation will be equal to. If this is at step 4, this is what we have. This is a step 3. See, you can relate the step number with the parameters you have here. 8 raised to power 4, so step 4. an minus 4 and step 4. So we can figure out that at step K, we are going to have 8 raised to power K multiplied by an minus K. So this is what you need to guess, okay, and figure out. So this is at a step K. This is what you will get as an equation. So this is at a step K. Now this is not the final answer. Now I need to see what is the relationship between n and k, because the answer should be in terms of n, not k. K is the step number, but n is the index. How far we are going to subtract? See, we are subtracting minus 1. minus 2, minus 3, minus 4. You will keep subtracting until you reach the initial value. If you recall that if we ask you to find 100 by a recurrence relation, what you would do? You need to find A99. And from A99, you need to find A98, A97. You go all the way until you reach the initial value. So this subscript will keep decreasing until it reaches the initial value. So what we should write? We should write here, this will continue, okay, until an minus k, or we can just remove, we don't want to say until an minus k is equal to, what is the initial value? The initial value is equal to A0. Okay, so A0. Don't write 7, A0, because A0 is the term. So until we reach A0, and if these two values are equal, so that means these also should be equal. And if these are equal, we can say that n minus k is equal to 0. So the value of k is in fact equal to n. Substitute for this value, okay, into this equation, and also n to this equation. So what you will get? You will get an is equal to 8 raised to power n multiplied by a, because n minus n is 0, and this is equal to 8 raised to power n, because a0 is 7. So this will be equal to 7 multiplied by 8. And this is the final answer for our example. So the method is called back substitution because we find the answer from the last term. So as a draft, we try to find some of the terms, and then substitute those for the recurrence relation, and it's called back substitution until you get the final answer.